Okay, it was lucky that the camera ran out when it did because I made a slight error here. This negative hadn't been typed in, so it winds up being 99.4. This is 99.4 degrees for angle A. Okay. Well, once you know one angle using the law of cosines, you can then use the law of sines to fill in the other angles. So angle C, actually I should say the sine of C over 11 is going to be equal to the sine of 99.4 degrees over its opposite side, 20. And when I type that into the calculator, I'll do sine of that answer, and then, whoops, delete, and then sine divided by 20, and then I'm going to multiply that by 11. And that's what the sine of angle C is. It's 0.54, so I'll do second sine and of that answer. And then I get the angle of 32.86 or 32.9 degrees. So angle C equals 32.9 degrees. And now that I've got two angles, I can add that with 99.4, and then I can subtract that from 180, and I'm going to get an angle of negative, I think it's 47.7, or sorry, positive 47.7. So that's angle B then is equal to 47.7 degrees. All right? So three sides, so I've got three angles, total of 6 things. All right. Make sure I talk quickly and get this done. This is the dreaded ambiguous case. This is an angle that's about 57 degrees. And I would recommend strongly that you put the one given angle on the left and draw this as being your going on forever until we need it to unknown side, where then this is going to be the side that hinges right here. That's going to swing. We do not know this angle, but we know that opposite of 57, opposite of B is side length B. So make this be the 11.9, okay? Then this is the 13.7, okay? And the question is this long enough to bridge that gap right there? And the gap, if you make this into a little right triangle, is always going to be found by the 13.7 times the sine of the angle that you're given, 57 degrees. Okay? So 13.7 times sine of 57 gives me a gap of 11.49 or so. So the gap is equal to 11.49. It's worth being pretty accurate because you need to compare that to this. Okay, so you compare, and this is bigger. Okay, it's bigger. And because it's bigger, I know that when it swings, it's going to come down and hit before it would be exactly vertical before that distance. And then what's going to happen? Well, 11.9 is less than 13.7, so it's going to come out just after. So I will hit in two places. So it hits in two places. So I'm going to get two triangles. So this is the ambiguous case. Oh, ambig, I can't write and think at the same time. Ambiguous case. And I get two triangles. Okay, and you could write an explanation, but I'm going to try to go quickly. So now I know I've got two triangles. One is when it hits on the outside. So I've got 13.7 and 11.9 and 57. I'm going to solve this one. And then I've got another case where it swings and it hits on the inside. And I'm going to draw it like this, so that this is my 57 degrees now, this is my 13.7, and this is my 11.9. The trick is that this angle right here, this is going to be the same as this angle right here, because as it swings on the inside, this will be an isosceles triangle. All right? I don't want to get it too confusing, but these will be the same length. So that is really important to remember. All right, so now I do law of sines. And I will get then the sine of 57 degrees over 11.9 is equal to, this angle here is opposite 13, so that's A, the sine of angle A over 13.7. So I'm going to do this super quick. Sine 57 divided by 11.9, and then I'm going to multiply that by 13.7. Gives me the decimal 0.96, and then I do second sine, inverse sine of that answer. Love that key function, and I get an angle of 74.9 degrees. So angle A equals 74.9 degrees. Well, if this is 74.9 degrees, then I can find this angle up here. I'm going to add this to 57, and I'm going to subtract it from 180, and I get 48.1 degrees. So that's angle, that is going to be, then if that's A and that's B, that's going to be angle C is equal to 48.1 degrees. I have everything except this side is C, so to find C, I'll do C over the sine of 48.1. I always put my unknowns in the numerator, and then is equal to 11.9 over the sine of 57. And crunch those numbers. And times that by the sine of 48.1. And I get 10.56. And that is, I guess, about right. So C equals 10.56. All right, so just be clear what your answers are. You should have 3 new answers to complement the 3 that you know. When I go over to this one now, I know this angle here is 74.6 or 0.9 for reasons I went into a moment ago. So 180 minus this is going to have an angle of 105.1 when I subtract that 74 from 180. So 105.1 plus 57, and then I subtract that from 180 again, and I get 17.9 is this little angle up here, and then I repeat the process to find the missing side over here. I've got all 3 angles, so that is angle C is 17.9, angle A, capital A, is the 105.1, and now I'm going to do law of sines to solve for this mini c. It's going to be exactly the same as before. It'll be c over sine of, in this case, it's 17.9, different from this one down here, and then also equal to 11.9 over the sine of 57. All right, so I won't show that because that just gets tedious. This final one. All right, let's see how I'm doing for time. I got about 2 minutes to do this. If a ship from here sails at a bearing of 55 degrees, so that's slightly below 45, so 55 degrees like that, till it gets to right there, and that is 20 miles. Now when it gets here, this is your new north. That's very important to know. This is going east. This is going south. So if this is 55 degrees right here, and then it turns and sails at 155, so there's 90, there's 180, so 155 is going to be something like that. For only 12 miles, it's going to be right about here. This is its final destination. Actually, final destination is home, but this is its new position. The question is asking, how far is this dotted line back to the origin? And it is not a straight shot east. Do not make that mistake. Don't draw it so that it looks like that. That would just be a coincidence. What I do know is that if this is 55 degrees, this also is 55 degrees. Think about why that is, but anytime you have parallel lines, these are both north, these are both parallel. all northerly direction lines are parallel, and I've got the boat sailing like this. If I know this is 55, I know that's 55 because of AIA. All right, so know that. Then, if this is 55 degrees, and if this here is 155 degrees, we just subtract from 180, and that is 25 degrees. So now really what I have is a very simple law of cosines problem where this is 20, this is 12, and this is 55 plus 25. That's 70, that's 80 degrees. Okay? And we're asking, what is this distance? Call that d. I don't know. Well, then I go d squared equals 20 squared plus 12 squared minus 2 times 20 times 12 times cosine of 80. All right? And I crunch those numbers. And that's 400 plus 144 is 544 minus 2 times 20 times 12 times cosine 80. Hit enter, and I get 460. That's d squared. Never make the mistake of writing that down. It'd be kind of silly if you sailed off 20 miles and then 12 miles and decided it was 460 miles home. And I raise that to the 0.5, or I take the square root, and I get d then is equal to 21.46. All right, so that is my distance home. You're halfway there. You'll get way more than half credit. The question is, though, what is my bearing to get home? Well, right here you could guess that if this is north, you're going to go all the way around to almost straight east. But if I could figure out this angle here, I'd have it, because that would tell me how much less than straight east it is. So if I can find that angle theta there, I'm good to go. So let's do that. Here's this angle theta. The sine of theta over 12 is going to be equal to the sine of 80 degrees over 21.46. Why did I choose that? Because these are the pair of things that I know. I happen to know that d equals 21.46, and it's opposite the 80. So I take my calculator, and it is the sine of 80 divided by 21.46, and then I'm multiplying this by 12, and I get 0.55, so I do second sine and second answer, and I hit enter, and I get 33.4 degrees. So theta equals 33.4 degrees. Well, if this is 33.4 degrees, I do 33.4 plus 55. That equals 88.4 degrees. And so that is just the thinnest sliver that's left over right here. That's only 1.6 degrees right there. 1.6 degrees. So from the north, I go all the way around, and I'm just 1.6 degrees less than heading straight west. So 270 degrees minus 1.6 degrees equals 268.4 degrees. So that is my bearing. All right? And if I was doing this on a test, I'd write it a little bit more carefully, but this is my distance. All right? And you could just write that in a sentence and you'd be done. Good luck.